Hello everyone, welcome to Data Discovery. At this video, we are going to see the concept related to log normal distribution. As in our statistics series, we have gone through lots of the distribution, the probability distribution, probability mass function, probability density function, cumulative distribution, lots of the distribution that we have seen. Each and every distribution gives some of the other describe of the data. Same, the log normal distribution is also heavily used. So from our data that we are having from any of the features like f1, f2, f3, so we used to plot it, and based on that we used to describe the data. So by each and every distribution you will be getting some of the other the data picture or data story that we can get it, right? So over here we are going to discuss about the log normal distribution, what's the rule related log normal distribution, and the most important code that we are going to discuss at this video. Let's get started. A log normal distribution is a heavily tailed, a continuous distribution of a random variable whose logarithm is normally distributed. It's nothing but a quite a right skew data from the plot itself. You will be getting that, you will be getting some of the right skew data. So not every right skewed is normally distributed. Like, not every right skewed it's normally distributed. It's normally distributed. It means if you're finding the log of x, if you're finding the log of x and it's normally distributed with mu and sigma, normally distributed, then it's said to be as a log normal distributed. Okay, so the condition is, if log of x it's normally distributed, then it's called as a logarithmic normally distributed. So in the logarithm log normal distribution also, you're dealing with only two parameters, that is nothing but by mu and sigma. With my mean and standard deviation only, you are just finding it. So if for example x is log normal distributed, x is log normal distributed of mu and sigma, then logarithmic, that is nothing but log of x, it's also equal to, it's also similar to normal distribution of mu and sigma. It means that if x is logarithmic normal distributed, then log of x also it's a normal distributed. So it's something related to log normal distribution, in which we are dealing with the normal distribution of the mu and sigma. Like from the three plot you have what you have seen that mu is equal to 0, that is nothing but a mean is equal to 0. But the standard deviation is different. The standard deviation is slightly deviated from the positive side and negative side. So it's slightly little if you can see, it's a right skewed data, right? So it's looking like a right skew data, but not every right skew data it's a normal distributed. So the most important part, not every right skew data, not every right skew data rs, it's normally distributed data. This is the most, it's looking like a right skew data, but not every right skew data is a normally distributed. So this is something related to a log normal distribution. I can give a very good example. The most important part that we can say, the salary of our country. So if you will see that there are very less number of the people who's securing the highest number of salaries, and there are very most number of the people who's having less number of salaries. Okay, I'll just repeat once again. So there are very less number of the people who's having more amount of salary. Salary is more, and there are more amount of people. The probability is comparatively more, but the salary is less. Okay. So in our country, the salary description that we have given, first example, very good example is salary. Second, I can give it of comments. Okay. It's nothing but there are very less number of people who sees the video, the YouTube video of completely. If it is 5 minute video, they used to see it completely. If they are interested, then definitely they will be seeing. But still, they will be hold till 5 minutes. But very less, very there are large number of the people who used to get back within a 1 minute, or within a less than 1 minute. So this is the another example for the log normal distribution. But the log normal distribution is heavily used in most amount of data, more amount of data. It actually follows the log normal distribution. Okay, let's move to the code. Okay, now let's start with the code for the log normal distribution. It's nothing but logarithmic. It's a normally distributed data. Okay, by using log values, we are just calculating. But if you want to note it, you just need to note it like the x values and y values is nothing but the same. But anyways, you are finding the logarithmic values, but the x values are the input values, and the y axis is nothing but my probability density values. That is nothing my PD values itself. Okay, so based on that only I am just finding the logarithmic values. So by using a simple log normal, just calculates the log normal values. And once you have done with the, you have converted all the data in the log normal logarithmic values, you just put it in the histogram, you just get it. So it's a kind of a log normal distribution. It's a right skewed part. Okay, so I hope you have got through it. This all the code that I will be sharing in the description box. You will be getting my GitHub link. Just go through it, and then the most important, do like, share, and subscribe to the data discovery. I will be coming across more related data science, data analysis, MLDL, NLP related part of the videos, upcoming videos. So do like, share, and subscribe to the data discovery. Thank you.